Alright, so this is your cyclohexane conformation. Yeah, and so if you see it on the top, looks like a cyclohexane, your regular type. Yeah, but if you see it from the side, you see that this is a chair conformation. Yeah, looks like a chair. This is the back, this is the portion at which you would sit, and this would be the leg of the chair. Yeah, so it has that that type of shape. That's why it is called as chair conformation. Yeah, and so if you look at the bond angle, yeah, it's wavy, and therefore the bond angle is 109.5 degrees. If you see that, you can see from the top. Okay, now from the top you see that these three are the axial hydrogens. Yeah, that's why they are on the top, and they are alternating with the equatorial hydrogens. So this is axial on the top, equatorial on the top, axial on the top, equatorial on the top, then also axial on the top, then equatorial on the top. Okay, and so when the ring flips, you basically get the other situation. So now equatorial is on the top. Yeah, so you only see three equatorials, and then equatorial, axial, equatorial, axial, equatorial, axial. So the position of the axial and equatorial alternates when we see it from the top. Yeah, so that's your cyclohexane conformation. Now if you see any two bond with a Newman projection, okay, and so let's say these two carbons, yeah, we want to see what is the conformation of the bonds in this two carbon-carbon single bond. Yeah, and so we view the molecule, rotate the molecule, and you can see that they are staggered. Yes, they are perfectly staggered. Yeah, other people? Okay, now let's see another bond. Yeah, so this was the first situation. We rotate again between carbon 2 and 3, and you see that that is also staggered. Carbon 3 and 4, you see that that is also staggered. Carbon 4 and 5, you see that it is also staggered. Carbon 5 and 6, staggered. Yeah, and so because things are staggered in this conformation, and there is no bond, there is no angle strain, there is no torsional strain, because everything is staggered. Therefore this is the most stable conformation of cyclohexane. Are you clear on this? Okay, so this is the side view. This is how it looks like. This is how we see the molecule. This is the top view, and remember that when you see it from the top, you see only three axial hydrogens, because the three axial are hiding below. Yeah, okay, so with that in mind, let me